In this lab, we're going to look at detecting radiation. Radiation being alpha particles, beta particles, or gamma rays specifically. So what we have here are two different ways we can detect radiation of any kind. This guy here is basically like a portable version of this here. So we're going to start with this. This is a Geiger counter. Okay. The way it works is you turn this on here, calibrates, and it will start to pick up any radiation that passes through this little window here. Okay. Those little clicks are part of the output that tells us that something has crossed through this little hole that has had enough energy to basically make an electronic signal inside here. So when something passes into this window that is carrying enough energy to kind of do some stuff with this little tube inside here that's full of some low pressure gas, we're able to make basically an electronic signal that this amplifies and reads out as a number and gives us a little click to kind of indicate that something has come through. Okay, so that could be an alpha particle, it could be a beta particle, or it could be a gamma ray. And just from the counts here, there's not really a way we could tell easily. It's just saying, hey, something flew in here that was strong enough to cause, a disturbance in the gas that's inside here. Okay, now this has something very similar. It also has an opening and a Geiger-Müller tube that is full of a low-pressure gas that you can set off an electrical signal with by having a high-energy particle or ray of light travel through that gas. The tube is up inside here. Now, these openings on this guy or on this guy are very delicate, so even just pointing at it, sometimes I get a little nervous. The one thing you don't want to do is go fishing around inside here to try and find, where's the tube or something like that, because it can break something pretty easily. So you just have to kind of take my word for it that our detector is up in the top of this hole here. So if any radiation comes up through that opening, then we'll be able to count it with one of these guys here. And just like with this Geiger counter, it just counts alpha, beta, gamma, all the same. Anything that passes through there, it's enough to give a signal. All right, so I'm going to turn this guy off. Move this aside. All right, so this is called a nuclear scaler. It's going to count radiation for us. All right, so anytime a number pops up, kind of like the other Geiger counter, it just basically counts for one alpha, beta, or gamma emission coming through the detector in here. All right, so there's a switch on the back to turn this on when it's plugged in. All right, it's now got a readout. There are a couple things we have to do to set this up. Since we're looking for an electronic signal in here from something passing through the detector, we need to make sure that our voltage is set correctly. So this HV stands for high voltage. If you press this, we can now use the up and down buttons to change the voltage. We want a voltage of 440, so let's up this. There we go. All right, when I'm done, I just press the HV high voltage button again. So it unselects it, so we go back to kind of our starting place. Now, in order for us to collect radiation, rather than just turning it on like the other Geiger counter, the little handheld one, this one we set on a timer, and it will continue to count radiation as long as that timer is going. So to set our timer, we're going to press this button here that says time, and we're going to up it for, let's say, 30 seconds. So half a minute, right there. Okay. Now, to say that I'm done selecting the time, I'm going to hit this button here. Okay. Now, this is showing that our timer is on 0 seconds out of the 30 seconds, and it hasn't started going yet. So if I want to actually start counting radiation, I need to hit the button one more time, so I'm fully back to the start. So now the 0 is showing 0 counts. Okay. When I'm ready to start counting radiation, all I have to do is hit this button right here that says count on it. And as I do, we start getting some numbers showing up. If you want to see how much time you've gone through in your measurement, all you have to do is hit the time button. There we go. So we're at 12, 13, 14, 15 seconds out of our 30. I can deselect this so I can see my counts again. And this will go on its own. It'll shut itself off of keeping count once it passes through that 30 seconds. You'll notice that this light will come off once the 30 seconds has gone by, so we know that the detector is done taking measurements, just like that. Okay, so in 30 seconds, our nuclear scaler has picked up 15 counts of radiation. Now, I have some radioactive sources over here, but even if I nudge these off to the side, and I count this again, I will still get a number up here that is definitely non-zero. We live in a world made of stuff, and that stuff sometimes includes things that are radioactive. And so you'll have stray alpha, beta, and gamma radiation sometimes passing by just from the stuff that makes up the world around you. There are a lot of things that might surprise you that are radioactive. Even the potassium isotope in bananas can be radioactive. So all kinds of surprising stuff out there. Now, does that mean, oh my gosh, I gotta be worried because there's radiation all around me? Well, it all matters about dosage and how much actually makes it to you in a harmful way. So in this lab, we're going to be looking at how distance affects the power of your radiation, how it can make it from one place to another before it maybe gets intercepted. We'll look at shielding, how you can block certain types of radiation, and what kinds of shielding are most effective against what different kinds of radiation there are. Okay, so we're going to be doing 3 trials here of just background radiation, is what we call it. So I'm going to hit count again, so it starts over from 0. So our first 30 seconds gave us 15 counts of radiation. Now again, now that I've moved kind of those radioactive sources off to the side, so far we don't have much going on here. We're still sitting at 0. Oh, there's 1, 2. So again, that could be 2 alpha particles. It could be 1 alpha particle, 1 beta particle. Maybe some gamma rays are coming through here. It's just stuff that's coming around from our environment. And just a couple alpha and beta particles coming around or a stray gamma ray here or there is not going to be the end of the world. We actually live with it constantly, and with a low enough dosage, you'd never even notice it. Okay, again, if I want to check and see the time, I can hit the time button, but our count button has had its light turn off, which means the 30 seconds has passed. And so for this trial, all I have is about 4 counts. We can do this one more time to get a third trial. And we can average it out to see roughly how much radiation is kind of passing by here just from the background, just from our environment, within 30 seconds. Now you'll notice it isn't happening the exact same every time. Even now that I've got the radiation sources off to the side and a little bit farther away, we're still not going to get probably the exact same number, or at least not at the exact same rate, because our radiation is somewhat random. Even when you have a particular radiation source available to shoot radiation right up into the detector, you end up with usually some different numbers because the process of decay of your isotopes changing to become more stable is going to be somewhat random. It's not a very particularly predictable process. They kind of pop when they're ready. So even with very specific positions for a radiation source right near the detector, you're still going to get some variance here and there. So we take an average just to see kind of a general idea of how much radiation is getting pumped out in a certain amount of time. Okay, so that would be our 3 trials for our background radiation. Now let's try and get some of these radiation sources in here. So these guys can put off different types of radiation. So in this disc here, or in this petri dish, I've got an alpha source, which is this guy right here, the thin yellow one. I've got a beta source, which is kind of the thicker green one. And I've got a gamma source, which is kind of the thicker orange one here. So what that means is these contain radioactive isotopes in very small amounts that are going to put off some radiation for us. So this yellow one contains polonium-210. It's going to go through alpha decay and therefore kick out an alpha particle every time a polonium-210 atom goes through a nuclear change. Let me see if I can rotate this one. Our beta is coming from strontium-90, and our gamma is coming from cobalt-60. Okay? Now, in general, we want to keep these as far away from us as possible, so we're going to be using forceps to move these around. Just the more distance between you and the radiation source, the better, the safer it is. Okay? Now, to be able to have our detector pick this radiation up, we're going to open this up here. This little panel has a whole bunch of shields we can use to kind of block radiation, and also in the 5th slot has a little plastic tray. It has a nice little circular indentation on it that you can use to place your radiation source on. So we're going to start with the alpha source, which is the thin yellow one. Okay, so again, you'll want to pick it up with forceps and place it in here. Okay, now we're going to put it label side down to make sure that the paper on the other side of the disc does not block or interfere with our radiation source. Okay, I'm going to place that in the top slot so it's right near the detector at the top of here. All right, we're still going to go with 30 seconds, and I'm just going to start the count and see if it's any different than the background radiation or if it's roughly the same. Let's see. All right, so we're kind of already off to the races. 19, 22, 24, 27, 28, 29, 32, 30, 40, and it's climbing. So it's already going quite a bit faster than just the background radiation around us. So again, we'll let this count for 30 seconds. And then we're going to do 2 more trials and average these out too. So for this first trial of the alpha decay, we've got 150 counts of radiation. And since this radioactive source is meant to go through alpha decay specifically, we can expect these to be 150 counts of just alpha particles. Now, some radioactive sources are not so simple. Sometimes they go through multiple different kinds of radioactive decay, but we're going to assume that all of this coming out from here is just alpha decay. Let's take another trial. This time I went even higher, went to 187. Let's take one more. Okay. Keep in mind, whenever you're averaging results, you're adding up all your results, dividing it by how many measurements you took. So in this case, and in the background radiation case, we took 3 measurements, 3 trials. So you'll be adding up your 3 counts from those 3 trials and dividing it by 3. All right, and this one landed at about 144, so less than the first one. So you'd average up those 3 numbers by adding them together and dividing by 3. Okay. Next up, we're going to switch out our alpha source, again using the forceps, so kind of some big pair of tweezers to move them around. So we're going to switch out the alpha source for the beta source, which is our little green disc. So we're going to pull the plastic tray out, swap this here. All right, now this time we're not going to put it all the way into the top slot. We're going to put it into the 3rd slot down. All right. We're going to start with a 30-second count. Then we're going to move up to a 60-second count, and then finally an 120-second, or at least close to it, 100 seconds. Depending on which scaler you're using, whether it's an old model or a new model, it might only go up to 100 seconds, and then it jumps to 200, and you can't do 120 in between. So for this model, we're probably just going to go with 100 seconds. Okay, so we're going to start this with our beta source now. It's a little bit farther from the detector than the alpha source was. The alpha was like right up against it. Okay, and again, in this case, we have the label down just in case. We don't want it to get kind of pre-blocked by anything. So let's go ahead and hit count. Oh, and it's going. It's like rocketing up. So already like way past, let's see, we've only been 9 seconds in. And we were like way past the amount of alpha that came off of this. Okay, now that doesn't necessarily mean that the beta decay and the beta radiation that's coming off of this is more dangerous than the alpha. It's kind of context specific. Some of this will depend on how well this radiation penetrates. In other words, what your beta particles can make it through before they get blocked by something or absorbed by something, and as well as how dangerous the actual radiation actually is, which we'll kind of get to here in a bit. All right, so that was our first trial for 30 seconds. Now we're going to set it up to 60 seconds and see how this number changes. So we're going to go to time, click that in, we're going to up it to 60 seconds, I'm going to click time again, and then click time again. Oops, there we go. So we can get back to our count. All right, so now when I hit count, this will count radiation for 60 seconds, still with our beta source in the same spot. So we aren't changing how far away the beta source is. All we're doing is allowing it to collect data for longer. All right, checking the time. Okay, so we're a little over halfway through. All right, so there's our second trial for our beta radiation at the third slot down, going for 60 seconds. In the one before, we had about 1,200-ish counts of radiation, and now for twice as long, we have about 2,400-ish, which is about a double amount of radiation for double the time, which holds up pretty well. So we got a nice pretty ratio that says our radiation is coming through pretty steadily. It's still a random process, but over time it shows a trend of a rate of how fast that decay is happening, which is pretty cool. Okay, so let's do one more of these. Okay, again on this model, we don't have an option for 120, we have 100 or 200. So we're gonna go with 100 instead of 120 seconds. I'm gonna click off our time again and start our count. So since we can't go to 120 seconds here, we shouldn't see this double quite as much again. So we shouldn't expect to get like 4,800 counts, but we should get something kind of close to it. So maybe ballpark 4,200, 4,400. You can probably work out a ratio if you want to see kind of the 60 seconds to 100 seconds and be able to math it out to figure out what amount of radiation you could get from this. So if you got to wait for 100 seconds anyway, or at least like 65 more, yeah, maybe that's a little math thing you can do while you're waiting. While that's finishing up, well, I got some time. I'm going to bring these over here a little bit and hope it doesn't mess with the measurement too much. Okay, but I've got the handheld Geiger counter from before. If you ever watch kind of a sci-fi movie, sometimes you'll see this where they have something that goes around and clicks on things. So I wanted to show you what it's like when this gets near a source of radiation, like what's in here, where it starts to have some more rapid clicks, or what's over here. So if you've ever been watching a movie and you have the guy going around with this machine, and sometimes it's got a probe on the end, and it's making a whole bunch of clicking noises, like that might be what they're kind of trying to indicate as radioactivity with a Geiger counter like this. Okay, so hey, just like we predicted, wasn't quite up to what we expected for like another doubling because we didn't double the time this time. We got a little bit close, okay? So I'm interested to see if this actually matches up with the ratio of 60 seconds to 100 seconds as 2,400 is to this number right here. I have to do the math myself, but hey, maybe, again, you have some time on your hands and would like to check that out for yourself. Okay, so the longer you have the radiation source, kind of letting out radiation, the more exposed you're going to be, the higher dose of radiation you're going to receive. So the less time you have handling radioactive materials, the safer you're going to be. And again, that doesn't necessarily mean that as long as you are very quick about it, you can handle anything radioactive, because there's other things that affect that too. But at least it's not as bad if you make it fast and you keep yourself as far away as you can. Okay. Next, we're going to be looking at the effect of distance. So we're going to keep the beta source in here, but we're going to move it down to the 6th slot. Okay, so in other words, the bottom slot. So let's take this, slide it down here. All right. We're going to go back to doing this for 30 seconds. So I'm going to step this back down. All right. So we're going to be comparing the beta radiation, the beta decay coming off of this into the detector at 30 seconds each time, but we're going to change how close to the detector it is and see how that affects things. So let's start with this one. All right, still fairly rapid, but we'll have to compare it and see how it is when it gets a little bit closer to the detector. All right, so there's our first trial of data for 30 seconds. We only got 366, which is quite a bit less than what we saw in the last one. All right. Next, we're going to move it up to the 4th slot from the bottom. So we're going to be moving it up 2 spots. So 1, 2. Okay. So for this first one, we had 366 counts in 30 seconds. Let's see what we get. We move it up a little bit closer. Looks like we've already kind of passed the point from before. All right, so there's our count for 30 seconds of the 4th slot down instead of the 6th slot down. Let's go for one more, and this time from the 2nd slot down. All right, still 30 seconds. Let's count it. All right, quite a bit more. Now, just to kind of bring the point home, we aren't changing the distance from the detector all that much. So this is a millimeter ruler. So let's see. So from the 6th slot, actually let me turn it like this so I don't do the math in my head. From the 6th slot up to the 2nd slot, move this out of the way. From there to there, we only went up about 40 millimeters. Okay, or about 4 centimeters, which is really not a lot, okay? And yet you compare the 360 some counts of radiation that we got the first time to this 2,719. It's a pretty big difference, okay? Now, when you're dealing with radiation like alpha and beta, where you're having actual particles fly through, just the effect of having air that has to bump through can decrease how much radiation actually makes it between you and the radiation source. So again, even a little bit of distance can be very helpful in keeping you safe. Okay, so do not take that lightly. You're always going to make use of that when you're dealing with radioactive materials. Okay, and you can think of that even more if you were to take a bigger distance than just 4 centimeters. Then you can really increase your ability to be safe around stuff that's releasing radiation. Okay. So for our last set of stuff, we're going to be looking at the comparison of shielding versus exposure of radiation. So now we're going to start putting things in the way and see how that blocks the radiation, if it does at all. Okay, so on all these, we're going to be looking at it for 30 seconds, so we don't need to change our time, but we are going to change what radiation source we use and what we put in between the radiation source and the detector to see if we can block effectively the radiation that's coming out of our source. Okay, so we're going to keep our beta source in the second slot from the top, and we're going to use some of these shielding options in this panel here, okay, to see how well it blocks things. Okay, we're going to start with shield 2. So this is shield 1, this is shield 2. All right, that's just this thin little window of plastic. Now these plastic casings around this are pretty fragile, so you want to be careful with these. Please don't drop them because they shatter pretty easily, and you'll get to see a couple examples of that in some of the later shields. Okay, so we're going to slide this shield in just above our beta source. That back there. Okay, and we're going to let it count. So again, we're comparing this in the same spot as before. So when we were doing the beta decay from 2 slots away from the detector, we got to about 2,700 counts. So if this little thin sheet of plastic is going to block any of this beta radiation, in other words, these little high-speed electrons coming from this process, then our number should be a little bit lower. And it looks like it's in about the same place, but maybe a little bit better. Let's try some other shields and see how they fare against blocking our beta radiation. Okay, so let's pull one of these out. Okay, so we're going to switch shield 2 for shield 7, which is this guy right here. Okay, now on these panels, it'll have a list of which slot is which. So I just pulled the shield 7, and also sometimes it'll have a little number on it. So this is shield 7, and it'll also tell you what thickness that you're dealing with and also what material you're dealing with. So this is aluminum, so we're going to be sliding in a piece of aluminum in between our beta source and the detector, and we're going to count for 30 seconds. So already the radiation count is significantly less, or at least it's at a lower rate. It's definitely not coming through to the detector as fast. So we're definitely intercepting some of those beta particles, those high-speed electrons, from reaching the detector. Okay, and that piece of aluminum isn't all that thick. Sure, yes, it's thicker than a piece of aluminum foil, but it's not like 3 inches of aluminum in between the radiation source and the detector. Okay, so comparing to the 2,000 some counts of radiation that passed right through the little piece of plastic that didn't really do much for us, we only got 110 counts this time with just that sheet of aluminum. Let's try shield 8. All right, shield 8 is going to be, looks like this guy here. Okay, so again, it's got the number 8 on there. So 8 is a thin piece of lead. So let's put this in there. I don't think it will matter which way is up, so I'm just going to do that side so you can see the shiny side. You can see it's a piece of metal. All right, so let's hit the count button. Oh, we got a couple. But it is remarkably slower than what it was before. Oh, we got 7. Wonder if we're gonna make it to the double digits. Ooh, it's gonna be close. Ooh, 9. Nope, didn't make it to 10. All right, so just that sheet of lead blocked a lot of that radiation. Okay, it's not even a particularly thick piece of lead. All right, we've got one more shield to try for our beta source. Okay, and that is shield number 11. So let's pull this guy out. Okay, now this one is especially what you had to be careful with, because this is a thick piece of lead. It tends to get kind of stuck in these slots because the plastic casing tends to start to break a little bit when people drop these. I think they tend to drop them because they don't expect it to be so heavy. So I want to remove shields 9 and 10 so I can get to this one a little bit easier, so I don't further break it by trying to force it out. And it is really wedged in there. Ooh. Okay, so if anything, this is a testament to why you do not want to mishandle the shields, because otherwise they'll get stuck in here and then I'll get in trouble for having the shields break. So what I'm going to do to be safe, I don't want it to get any worse right now, well, especially while I'm recording it, is to go grab a shield from a different set, and I'm going to use that one. Hey, looky there, there's shield number 11 from a different set. Okay, now this one's mostly intact, which is nice, but even then, the casing's already starting to come apart. And when that casing starts to come apart, that's when it gets wedged into spots like this. Okay, so I'm gonna close this up for now. All right, we're gonna put this thick piece of lead in between our beta source and the detector. All right, let's start our counts. Ooh, 13 actually made it through here. That's kind of surprising. Okay. Now we would expect a trend of having less radiation passing through a thicker piece of lead, so I think that's an anomaly. I wouldn't count that up as, the bigger the piece of lead, the more radiation you get through or something like that. Usually the thicker your shielding, the better. So kind of an interesting result there. A good testament to how our radiation and our radioactive decay is a random process in the end. Okay, so now what we're going to do is swap this out. Instead of using our beta source, we're going to switch to our alpha source. Again, with the label side down. Then we're going to try these different shields. Again, 30 seconds each time. So the first one's going to be the alpha source with just our shield number 2, this little thin piece of plastic. All right. So let's start the count. Ooh, we got a couple. All right, only five alpha particles made it through. Okay, now just to show this isn't, a trick or something like that. This is still the active alpha source from before. I'm taking the shield out and I'm going to count again. And there it goes. So I'm going to stop it now, but just so it's not, a trick or something like that. Let's stop that. So only 5 counts of radiation just from this piece of plastic in between it. Let's try shield number 7. Place that in there, start our count. So this is our sheet of aluminum. Okay, looks like we've still got a couple slipping through. But it's still a very low number, especially compared to the 160 some or so we had from the beginning, where we had no shielding at all. Let's switch to our shield number 8. This is our piece of lead. Let's try this side down this time. Okay, still a few, but not all that much. All right, now time for shield 11. Here we go. So whether you are putting a sheet of plastic in between or a piece of aluminum or lead, alpha particles are kind of like little atomic bullets. They can pack a punch if they can hit some unprotected tissue, like if you were to swallow something that's emitting alpha decay and alpha particles. But from the outside, it isn't too harmful. Even just layers of clothing can be a good defense against keeping the alpha particles away from the stuff that you're made of that can be sensitive to being damaged down to the cellular and atomic level. Okay. Now, the last source of radiation we haven't done yet is gamma. So let's switch to that. Let's go in the second slot. All right. And we're going to start with shield number 2 again. All right, let's hit count. We've already got quite a bit passing through here. Now, aside from just the ability to penetrate through materials, gamma radiation also carries with it some danger of being very high energy. So basically, it's light, but very high energy light that has the ability to ionize the stuff that you're made of. In other words, it's able to knock your electrons around, which greatly affects how stuff works inside your body. All right, let's step it up to shield number 7. So our piece of aluminum, or put a piece of metal basically in between it. Okay, so even if you don't get as big of a dosage of one type of radiation to another, it doesn't necessarily mean it's a safer situation. So gamma radiation can pack a much bigger punch compared to, say, alpha or beta, for its ability to pass through materials like this sheet of aluminum and still carry with it a lot of energy to damage your cells, to ionize the molecules and things and break bonds down to the stuff that you're made of. All right, so still a lot got through our piece of aluminum. Okay, so just because it's a metal doesn't mean it can block our radiation well. It depends on the type. Let's try a piece of lead. shield 8. So even a piece of lead is still allowing through 224 counts of gamma rays coming from this radiation source. Okay, so let's see if the thickness of lead will do a difference. Time to bring in shield 11. Let's start the count. Looks like it's going a little bit slower. This is one of the reasons why gamma radiation is kind of the scariest one. Okay, even with a piece of lead, that thick, we still end up with 158 gamma rays coming through compared to the 220, 230 that we had with other stuff blocking the path. Okay, and so that's all we need for data collection. Just for comparison, I'm going to take this one shield out since we didn't use gamma for anything else, and allow it to just collect on its own for 30 seconds. So you can see how active this source is. So again, gamma is pretty scary, not only because it packs a punch, it's got a lot of energy that carries with it, it's basically just high energy light, it also can travel through a lot of materials. It's hard to stop it. Okay, so a lot of times it could take a pretty thick layer of lead or concrete or both to make it through this. Okay, so with nothing stopping it, we had a rate of about 240 counts in 30 seconds compared to the 230 or 220 from some of the other shielding materials. So not much there that could stop it once it got going. Okay, but we did have a pretty significant lowering from our shield 11, which does show that we can stop gamma radiation as long as we have enough stuff in between it that is able to block it, something like a dense metal like lead. Okay, so hopefully that gives you some ideas about how radiation works, how we stop it, how it's affected by distance, and what your different types of radiation are like. Okay, so things to keep in mind. Distance plays a huge part in how you receive radiation from something. So the farther away from the source, the better. You can shield from types of radiation, but it depends on what type you're receiving with how you shield from it. Alpha decay is pretty easy to block. Beta decay is a little bit tougher, but can still be blocked with something like aluminum. And then gamma is very difficult to block. You need some really thick lead or maybe even concrete to be able to keep the gamma rays away from other stuff that it could harm. Okay, and in the end, dosage is also important too. Just because you are receiving a certain number of counts of one radiation or another doesn't necessarily mean it's safer or more dangerous. If you're getting a lot of counts of, say, alpha radiation, but you have something in between you and the source to block it, it doesn't take much. A piece of paper could block an alpha particle, basically. Okay? Whereas if you're just getting a smaller amount of gamma radiation, that could still be more dangerous because there's not much that you can do to stop it unless you really put a wall in between you of lead and concrete and things like that. Okay? So hopefully this gave you an idea of what radiation is like.